Hello everyone, and welcome to what will most likely be the last update for the amazing spline tool we've been developing for the last 6 months, where you can put meshes along a spline, deform them, spawn them, and now include multiple meshes and have them randomize in a bunch of different ways. And this is all provided to you completely free of charge from this link on our marketplace page. But if you'd like to support our development, we do have the option for you to spend $5, and as a bonus, you'll receive the demo map we've been showing off in our videos. Huge thanks to those who have already bought it. Your positive reviews and feedback allowed us to be featured on the marketplace as the second highest blueprint in the April showcase. So thank you. For this update, we compiled all the community feedback you sent us and made it the primary focus. First thing up, we have expanded the demo map to include more panels showing off features from this update, which you'll see throughout this video. We also expanded the availability of the tool for Unreal Engine 4 users, with 4.27 now being supported. While we were at it, we also included 5.4 support. One of the most requested features of this update was to have multiple meshes be able to be placed along a spline, and now you can do that. Let me drag out a new spline and show how. By default, the spline now starts spawning in Unreal's default cube. We can see this by going into the spline meshes variable and noticing that this variable is now an array. So if we wanted this changed to a red arrow, we can drag it in and replace the cube. And if we wanted more meshes, we can click the plus button and add a couple more mesh instances for our green and blue arrows. If you are using Deformation, which is on by default, I will warn that it will space out your meshes by using the width of whatever mesh is in the first element. So if an element after the first is something longer like a guardrail, it will shorten it to be the same width as the first element. This is because this system is mostly supposed to be used for variations of a similar mesh. But if you are using periodic placement, the width warning I just gave doesn't matter because it won't stretch or deform placed meshes. To show a practical example where the width difference wouldn't matter, I could make a line of debris in this scene, which uses various different sized pieces of trash to make a litter-filled alleyway. And I'll show how to do this with the new features in the randomizing transform section later in this video. But returning back to the 3 arrows I have along the spline, you can probably see the pattern that they're using. It just goes from the first mesh to the second and then to the third, and it repeats indefinitely. You can overwrite the order by using the variable override mesh IDs along spline, and it's very similar to an array, but this structure is called a map. The first column of data is called a key, and I have it correlated to the position on the spline. When adding a value to this, it defaults to the key column being set to 1, and then 2, and so forth until it's completely filled, and then it will fill in 0. Using programmer logic, you all may know that 0 is the first element in an array or map, so it is correlated to the first element along the spline. One thing to note about a map is that you can't have 2 identical keys. By default, Unreal adds the key of 0 to the map, but my code quickly switches it to the next element that can be added until all positions are filled, and then it fills in 0. I did this because once 0 is in the key column, it won't allow you to add another element because it will only add elements with a key of 0. Since there would then be 2 keys of 0, it will throw an error message and not allow it. So if you make your spline longer and need more elements in your map, delete the key of 0 and add it back when you're done. Now, the right column is what is actually in charge of setting the variation. We have the entire map's value column filled with 0, which just makes the mesh ID equal to 0. And just to be clear, the ID number is the same number related to the element of the spline meshes variable. Since the red arrow is at index 0 of the array, all the arrows are red. But if I change the index 0 to green, it's now all green. So hopefully you can now see the logic of assigning a mesh to be certain variations. I have a demo panel as well that goes over all of it. And one thing that I did not cover, that the wall does point out, is that if you assign a value of -1 to any mesh, it will be blank and not render it. It's cool for this example because I want to have spaces between some of the variations. Now that we have covered how to manually set the variations, we can now cover how to automatically make the variations random. So let me go into the demo panel that covers this. There are 2 very similar panels, but one is for the meshes that deform, which is default behavior, and then there's another one for meshes that use periodic placement. The process for randomizing data works the same for each panel. So let's take a look at this one. We have the same 3 variations of arrows that we used earlier. I just need to scroll down into the options and find the Randomize Variation button under the Randomization category. And what it will do is randomize the map variable that we just looked at. And now if I click it, we can cycle through random variations. Pretty cool. Now from looking at the randomization category, you can tell that there's a lot more to it than just mesh variations. The other big thing is randomizing the transforms. And transforms include location, rotation, and scale. In order to randomize these, we need a limit of how much you want the meshes to be random. So let's look at randomizing the locations. The two limits we need to set are the lower and upper limits. If you don't want any randomization, you can set both limits to 0. But looking at the example we have here, we can see that the upper limit is set to 100 for the X and Z axis and negative 100 for the Y axis. How you can read this is that the X axis is forward and backward movement. When the X axis value is 100, it means that I can move forward on the spline 100 centimeters. If it was negative, it would be going backward that amount. It is important to note that these values are all relative to its position along the spline. So the forward direction is different at the beginning, end, and everywhere else in between on the spline. Now for the Y-axis, it can move the mesh left or right. We have this set to go to a minimum value of negative 100, which is to the left. If it were positive 100, it would move it to the right. The Z-axis is probably the easiest to visualize. Its range is 100 centimeters, which means it can go upwards up to that amount, and negative values would be going downwards. If you need the whole thing to go up or down, remember from the last video, we have a vertical mesh offset variable that will raise or lower all the meshes this amount. To show a practical use case, I have UE5's Matrix Awakens demo open, and I can go into this alleyway and add some trash along the path. In order for it to not be a straight line, I can randomize the Y-axis, and it feels like a path of random trash has been added. This is just one example, I'm sure you can think of plenty more. And as always, a lot of the high detail meshes that I'm experimenting with are Megascans assets, so feel free to use them for yourselves. Back to the demo map, the next row is rotation, but that doesn't affect the spline if it is using deformation, since it would cause weird effects to have the meshes stretch that suddenly. But it does affect periodic placement, and you can see it places the meshes along the spline with the random rotation. The rotation range for a full 360 degree rotation in every direction is negative 180 for the lower limit and positive 180 for the upper limit. The last row in the transforms is the scale, and for periodic placement, it changes how you would expect. If you have a scale of 2 as an upper limit for, say, the Z-axis, then the mesh can be twice as tall. There is one main difference for the deformed meshes, and that is for the X-axis. It will always make the randomization of your mesh's scale add up to the length it would be if all the meshes were at normal scale. So if you add up all the scales from the indexes 1 to 7, it will be equal to 7. And that makes sense because there are 7 instances. It works this way because now you can add more length to the spline, and the spline doesn't have to worry about how much the randomized scales affected the length of the spline, because it virtually had no effect. Any new instances will be in the normal position and scale until you press the randomize button again. I know you may also be wondering why I skipped over the 0 index in the randomized data, and that 0 element is reserved for a unique feature to the deformation category called continuous deformation. This will make the previous mesh flow into the next one to make it seem like it is one continuous mesh. For this continuous deformation option, in order to make sure everything seems random, you actually need one additional point for the very start to be random, and that is what the index 0 is for. To show off this feature, I'm going to be using another practical example. In the puzzle game The Witness, you're trying to solve puzzles, and you often have to follow a cable from one puzzle to the next. Instead of manually editing the cable to make it seem like it was laid down by a person, you could just use randomization. This way you only have to worry about making the direct path and not the random path. The last feature of the randomization panel is the inverting axis, and what this will allow you to do is randomly reverse the direction of the mesh on any axis that you want. In this example, I'm flipping the mesh forward and backward randomly, and we can see this in the options where I've enabled Allow X-axis Inverting Variation, before pressing Randomize Transforms. It works similarly for flipping meshes left and right and up and down, although you won't be able to tell that from this arrow since it's symmetrical on those axes. And luckily for you, I have another practical example and one more game I want to add to my business tax write-offs this year. This being the story game Kona, and I guess Kona 2, which I noticed had very smart use of randomizing their fence variation, transform, and orientation in order to hide the fact they were reusing variations of their fences. When creating video games with a mostly realistic visual style, it's a big deal to hide repeating meshes because it may be distracting the player from what you actually want them to focus on. You could design a unique mesh for every fence, but that would take too much development time. So typically, what you would do is create a few variations and randomly cycle through them and hope the player doesn't notice or care. In this clip from Kona 2, I highlighted an area where the repetition was more noticeable just so you can see it a little bit better. Now, I'm going to show how to create a similar system using the Spline tool. So I've created 3 variations of fences, or technically 5, but 2 of them are just mirrored from the original 3. But from this we can tell there's an obvious repeating pattern. If we wanted to hide it, I can set the height of fences to have a little variation, I can fluctuate the rotation, and I can allow left and right facing inversion. Inverting doesn't do too much here because both sides are painted the same, but it would help if you used a material or texture that has a pattern that doesn't repeat on its front and back. It already looks a bit more random, but now it's time to randomize variation, and just like that, it's a lot harder to notice a repeating pattern. You can probably still see some repetition, but Kona has an advantage where you can't see too far in front of you due to the blizzard that happens in the game. And if I really want to minimize the noticeable repetition in my fence, I would probably use more than 3 main variations of fence. Now that we have the largest part of this update covered, there are a few supporting features that may help with some more unique problems. The first being mesh caps. If you want to begin or end your spline with a certain mesh, now you can. This is useful for our fence example because at the end of our spline it's just open. And we know that fences should have an end post. So we can go into this example and see that it has a post assigned to the end mesh cap variable. Another nice feature is that it will allow you to transform the capping mesh. I should also mention that the transform is local, so if you needed to move 1 meter to the right, it will stay on the right no matter how you move the spline points, like how I'm showing now. The next feature is a pretty basic one, but was a bit trickier to code than one might think. You can now scale your meshes that are used on the spline directly from this variable named mesh scale in the default options tab. You may be wondering how the forward axis affects scaling or whether it's local space or world space scaling, and for that the best way to explain it is that regardless of what you set the forward axis to, the X scale will always refer to the forward facing axis, Y will refer to the left and right axis, and Z will refer to scaling the mesh up and down, and it uses local space scaling. We also had 3 previous options to flip the direction of the mesh for each axis, but that has been replaced by just setting the mesh scale to negative. Please note that this is different than the blueprint scale, because if you set that to -1, you get the whole spline reversed from the pivot point. There's also another new option that will allow the scale of the mesh to affect how many instances of a mesh will be placed on the spline. This variable is called scale-based placement, and it will place the meshes one right after another based on the size of the meshes. When using deform meshes, this is kind of already implemented, but for periodically placed, you now have this option. The next feature we have is the place at spline points variable, and we have this example here in the demo map of electrical pylons, and this is a great demo because it shows how a deformable mesh can work with a periodically placed mesh. Both of these use the place at spline points variable, but for periodic placement it places the pylon poles at each spline point, and for the deformable cable it will stretch one instance of the cable between each pylon. It is important that your cable has enough polygons to deform downward if you're going to use the next variable called droopage. Droopage just allows the mesh to droop down, like what a cable being affected by gravity would do. Just a small function that I felt like adding when I made this demo panel. Another small feature that I added is that if you snap a spline to follow another spline, it will move anywhere the other spline moves in real time. This functionality was mainly achieved by moving the logic from the construction script to the event graph. And now that also means you can update any of these blueprint splines in real time while your project is running by getting a reference to the blueprint and just calling the function update spline. As a last minute request, we also had someone from the community that wanted to have periodically placed meshes be able to use static mesh instances instead of components. So now if this new variable is enabled, you will significantly reduce your draw calls and the number of primitives rendered. The one condition is that this can't be used with meshes that have negative scales because it inverts the geometry. Most of you won't notice the performance improvement from reduced draw calls unless you have something in your scene that's hogging it, or, like the person that requested it, you may be developing a project for mobile, in which case you are more likely to see performance improvements there. This is pretty much all the new features. All this is also included in an identical UE4 map. The only thing different I notice is that collision previews of the Spline tool don't seem to work in UE4. However, if you actually play the level, it does correctly compute the collision at runtime. Alright, that is everything for this update. Thank you all for your support. This will be my last update for this tool that I know of. Working on a free tool doesn't pay as much as working on a paid tool, but I do really want to thank those of you that spent the $5 on the tool through the marketplace because it did give me the time to make this update. The only thing I want to do for this, but don't seem to have the know-how to do, is how to manipulate spline twisting for deformed meshes. As you can see from the scrap demo scene, I wanted to show a roller coaster with loops using this tool, but unfortunately the spline twists in weird ways. I've dissected the math of splines and I understand why it does what it does, and everything can be traced back to defining what the up vector is, but unfortunately there does not seem to be enough control of it through the blueprints to get it to stop twisting. If anybody would like to add code and share it to the community, I would be happy to add it as a future update. But as far as feature updates are concerned, I think this will be the last one for this pack. So my focus is now going to be on the other pack that I sell called the Dynamic Road System. I'm hoping to have some really cool features get added to that. As you can see, I've already implemented a lot of optimizations and have expanded some line marking features, like you can see on screen. But I'll talk about that more in the next video. Thank you all again. Until next time.